Welcome to another video on Docker Essential Training. Today we are going to learn about container. So what is a container? In Docker, a container is a standardized unit of software. A container is a standard unit of software that packages up code and all its dependencies so that the application runs quickly and reliably from one computing environment to another. A Docker container image is a lightweight, standalone executable package of software that includes everything needed to run an application, which consists code, runtime, system tools, system libraries, and settings. Container images become containers at runtime, and in the case of Docker containers, the images become containers when they run on Docker engine. Available for both Linux and Windows based applications, containerized software will always run the same regardless of the infrastructure. Containers isolate software from its environment and ensure that it works uniformly despite differences, for instance, between development and staging. Docker's containers that run on Docker engine are standard Docker created in industry standard for containers, so they could be portable anywhere, and Docker engine can be lightweight. As containers share the machine's OS system kernel and therefore do not require an OS per application, driving higher server efficiencies and reducing server and licensing cost. Its container is secure as applications are safer in containers, and Docker provides the strongest default isolation capabilities in the industry. In this figure, you are able to see that a bare metal system is structured to accommodate a central and a number of containerized application. Here you see infrastructure, and above it the host operating system like Ubuntu, CentOS, RHEL, Windows, or anything else. Then a Docker engine has been installed there. Above the Docker engine, there are lots of container can be created, and applications could be accommodated there. Let's move to another slide. Here you can see Docker containers are everywhere in Linux, Windows, and data center, cloud, serverless, any infrastructure you can imagine. Docker technology was launched in 2013 as an open source Docker engine. It leveraged existing computing concept around containers and specifically in the Linux world, primitives known as C groups and namespaces. Docker's technology is unique because it focuses on the requirement of developers and systems operators to separate application dependencies from infrastructure. Success in the Linux world drove a partnership with Microsoft and brought Docker containers and its functionality to Windows Server, sometimes referred to as Docker Windows containers. Technology available from Docker and its open source project Mobi has been leveraged by all major data center vendors and cloud providers. Many of those providers are leveraging Docker for their container native IaaS offerings. Additionally, the leading open source serverless framework utilizes Docker containers technology. Okay, we can compare containers and virtual machines. We have shown on the right side the typical virtual machines, how their architecture uh, and how does it operates. And on the left we have shown the Docker architecture. Containers and virtual machines have similar resource isolation and allocation benefits, but function differently because containers virtualize the operating system instead of hardware. Containers are more portable and efficient. So the difference is containers are an abstraction at the app layer that packages code and dependencies together. Multiple containers can run on the same machine and share the OS kernel with other containers, each running as isolated processes in user space. Container take up less space than VMs. Container images are typically tens of megabytes in size, can handle more applications, and require fewer VMs and operating systems. On the other hand, virtual machines or VMs are an abstraction of physical hardware, turning one server into many servers. But the hypervisors allows multiple VMs to run on a single machine. Each VM includes a full copy of an operating system, the application necessary binaries and libraries, taking up tens of gigabytes. VM can also be slow to boot as it has lot of contents to allocate in their memory. Containers and virtual machines together provide a great deal of flexibility in deploying and managing apps. Okay, this other more thing you can container standards and industry leadership. It has several services uh, to to maintain or administer, and it's easier than a physical server. So we have learned about container, why it's efficient than a physical infrastructure or a VM. So that's it. Thanks for listening to me. See you next time. Bye.